In this video, which is titled How to Shaders, we learn how to approach creating some of the fundamental shaders, including plastic, parquet or wood generally, concrete, and metal. Hey folks, welcome to Masterclass. This video is a free sample from our course, The Ultimate Introduction to Arnold 6 for Cinema 4D. It's a massive 12-hour course in which we explore all the aspects of Arnold for Cinema 4D thoroughly. Make sure to check it out, the link is in the description. Also, be sure to subscribe and ring the bell to get notified about our latest videos. Let's start with plastics. I'm gonna create a new standard surface shader. Rename it to plastic, assign it to the shader ball, and run the IPR. And let's open up the shader itself. For plastic shaders, base color is the most important component and contributes the most to the final look. Let's use this yellowish orange color with the RGB values of 252, 190, and 10. And set the base weight to 1. Now coming down to the specular section, I mentioned in the specular lesson that for most materials and shaders, you can safely keep the specular weight and color at 1 and white to keep the shader as physically accurate as possible. In the past, we used to control specular weight and specular color and roughness and then define very specific IR values for each shader. Just forget that. In this new approach, specular weight is almost always 1. Specular color is just a simple white color. And the IR value for most daily shaders like plastic, wood, concrete, and so on can be around 1.5. The only thing we are interested in is the specular roughness. We add variations to the specular roughness with a grayscale texture, and that adds all the realism we need. So add an image node and load this BW1 texture. I'm gonna set it as the beauty shader and set its scale U and V to 2. As this map will be connected to the specular roughness, I'm going to change the color space to utility raw because we are in ACES. I discussed ACES in the introduction section and it will be discussed thoroughly in the rendering section. If we connect this map to the specular roughness, as we learned before, those dark patches are gonna make the surface sharper at those areas. We want the opposite, so let's invert the image. A quick way to do it is going to be by using a complement or invert node. We want to add this node after the image node. A simple way to do so is that you can first select the node that you want the next node to be after, then press Ctrl Tab and search for the node you want it to be added after. In this case, it's complement. Now if you press Enter, it will automatically be added after that node. Now the image is inverted. And finally, let's add a RAM float node after the complement and connect the RAM float node to the specular roughness input and set the standard surface shader as the beauty shader. I use the RAM float node to be able to adjust the texture values. As soon as we add this variation to the specular roughness, now we get a much more realistic shader. The map is a bit too contrasty and I'm looking for something more subtle. So I'm gonna select the darkest values using my RAM float node and increase them to something like 0.085. Now the sharper reflections become a bit rougher. Then I'm gonna select the brightest values of my texture, which are responsible for these rough patches, and set them to around 0.5. Now they become sharper. So this is the map after the complement node, and this is it after we adjusted its values using the RAM float node. So using this RAM float node, we made the darker values a bit brighter to make the sharpest parts a bit rougher, and we also made the brighter parts quite darker to make the rougher parts much sharper, and that is the shader we get. In terms of importance of components for plastic shader or anything similar, now we need to work on the subsurface scattering. So open up the subsurface scattering section, set the weight to around 0.5, 0.6. Depending on the particular plastic, the SSS weight can be quite low or high. You need to look at your reference image and see if it has a lot of SSS or not, and then decide on the subsurface scattering weight. Set the radius to around 1 centimeters. For the color, I'm gonna copy the base color and paste it here as well. And this really adds quite a lot to the overall realism of the shader. It's beautiful. The next thing to consider is to work on the bump mapping. For most surfaces, you need an overall unevenness that can be achieved with a simple noise, and then more high frequency details, which you can just reuse the specular roughness map for it. Now let's add a bump to the node. Now, should we use the original map or the inverted version? If I set the complement shader as the beauty shader, we know that these white patches are making the specular reflections rougher and the dark patches are making the surface sharper. If we consider bump map, these white patches will add bump and dark patches will add indent. And that is what we want. So connect the complement to the bump map input of the bump 2D node, and bump 2D node to the normal input of the shader, and set the shader as the beauty shader. The bump amount is clearly too much. Let's try 0.05 centimeters. Still too much. Let's try 0.01. You know, bump mapping can be a bit tricky. So when I add bump mapping, I tend to scale up the render to see what is happening in the final render. So let me draw a region and set the scale to 200% in the IPR. Now you see even 0.01 centimeters is too much for a fairly smooth plastic surface. Let's reduce it to something like 0.002 centimeters. I think this is good. We don't want to exaggerate anything. Subtle and little is always better. So that's the high frequency details. Let's disable the region and set the scale back to 100%. Now let's quickly add that general unevenness to the surface using a noise node. Most of the materials and surfaces surrounding us in real life are not made perfectly. It's not going to be perfectly smooth. There is some sort of waviness to it. And if you take a look at any reflective surface around you can see that overall waviness and unevenness to them. So add a noise node, set it as the beauty shader, set its scale to around 13. Now connect it to a bump 2D node and connect the bump 2D node to the normal input of our main bump 2D node in the chain. Now, if I increase the bump height in the new bump 2D node to something like 5 centimeters, you can see that's the type of unevenness that I'm talking about, but we want it to be subtle here. So let's set the bump height to around 0.4 centimeters. Now let's see what we get. Now this is a pretty good plastic shader and you can call it a day. One other thing that you can add to your shader to make it more realistic is to make the perpendicular faces a bit sharper compared to the parallel faces to the viewing direction. We can do that simply using the coat section of the shader. We talked about this specific topic in the coating lesson. For now, let's set the coating weight to around 0.5 and coat IOR to around 1.2. So the code will be limited to only the perpendicular faces and decrease the roughness to 0.05. And this will add another level of realism to the overall shader. We can go ahead and add a bit of variation to the code roughness, but this is enough for now. Now let me show you a final render for this shader. And here it is. Now the good thing is that this whole shader is being controlled with one map that is connected to both the specular roughness and bump input. If you load another texture, you would get an entirely different look. Now let's quickly turn this into a red plastic shader, duplicate the original one and assign it. And we can rename it to plastic red or something like that. Now we just need to change the base color and the SSS color to any other color we want. Let's go for a red color with the RGB values of 184, 37, and 37. And copy the same color to the SSS color as well. I think the roughness map can be adjusted a bit. I just want to make these rougher parts a bit sharper. Specular roughness map is not that contrasty. So select the ramp float node and decrease the Y value for the second point to something like 0.4. Now let's see what we get. And I can just show you the final render for this shader as well. Here it is. Very nice and touchable. So that's about the plastic shaders. Let's pick up the pace a bit and go for a wood parquet shader. Add a new standard surface shader. Rename it to parquet and assign it. Open it up. Load this wood parquet.png texture. As this is the base color texture, set the color space to utility sRGB texture. Let's set it as the beauty shader to see how it sits on the geometry. I'm going to set the scale U and V to around 0.75. Connect it to the base color and set the base weight to 1. Specular weight, color, and IOR can remain at the default state as we discussed for the plastic shader. Let's go for the specular roughness immediately and load this wood parquet bw02.png. Change the color space to utility raw and scale to 0.75 like our base texture. As the previous shader, I'm gonna quickly invert the texture as this texture was created for glossiness workflow, so add a complement node after it. Now add a ramp float after the complement to be able to adjust the texture. I'm just gonna make the dark values a bit brighter by increasing the first point Y value to around 0.2. Now connect this to the specular roughness and set the standard surface as the beauty shader. Next, let's go for the bump. For this, I want to use both the map that we use for specular roughness and add this second map as well. So add an image node and load this wood parquet bw.png to combine the two maps. Add a layer RGBA node and set it as the beauty shader. Connect the complement node to the layer 1 input and the second image as layer 2 input. Change the operation mode for the second layer to overwrite and set the mix or opacity to around 0.7 so we can reveal the first layer a bit. I'm gonna set the standard surface as the beauty shader and connect the layer RGB node to a bump 2D node. and bump 2D node to the normal input of the shader and set the bump height to around 0.15 centimeters. Let's add that general waviness like the plastic shader. I'm just gonna steal that noise and the bump map from one of the plastic shaders. So select them, Control C to copy and paste in the wood shader using Control V. And connect this bump 2D node to the normal input of the existing bump 2D node. Now let's add the coat. I'm gonna set the coat weight to around 0.3. Roughness can be changed depending on what we are trying to achieve. 0.1 is good here, and let's decrease the IOR to 1.2. And this is our final shader. Let me just show you this final high resolution render. Now let's quickly create a concrete shader as well. So create a new standard surface shader, rename it to concrete and assign it. Open it up. For the base color, load this concrete 01d.png. We can set the color space to auto, as the map will be used for specular roughness and bump mapping as well. Set this texture as the base color and set the base weight to 1. In the image node, we can disable uniform scale and set the scale U to around 0.8 so the map sits nicer on the shader, basically more squared. I'll be using the same map for the specular roughness as well, so we need to invert it. Add a complement node and use the image as its input. And now we have an inverted map. Add a ramp float after it in case it's needed, and now connect it to the specular roughness input. Depending on how much sharp or rough you want the concrete to be, you can simply adjust the ramp float and make it darker for sharper concrete or make it brighter for a rougher concrete. Specular weight, color, and IOR can remain at what they are. Finally, let's add a bump 2D node. Set the bump height to around 0.1 and use our original map as the bump map input and set the bump height to around 0.1 centimeters. And here is our final render and final shader. Let me just show you here. You can add the second bump map like the previous shaders, but in very rough surfaces like concrete, it won't be that visible. And the same thing is true for the coat component. Finally, let's create a metal shader. So create a new standard surface. Rename it to gold and assign it to the shader ball and open it up. In the second lesson of this section, we talked about metalness and how to create metal shaders. In this case, increase the metalness to 1 and use the gold preset to get started. Immediately, let's work on the specular roughness. I'm going to add an image node and load this map that is called metal roughness and set the color space to utility raw. Add a ramp float node after it and connect the ramp float to the specular roughness input. You see the result is a bit too rough, so in the ramp float node, make the brighter parts of the texture that cause that roughness to be a bit darker, maybe from 1 to around 0.4. So imagine basically if you decrease the roughness value itself from 1 to 0.4, it would make the overall shader much sharper. And now we are basically doing the same thing by making the brighter values quite darker. Therefore, the overall shader will be much sharper. I'm also going to select the texture itself and set its scale to 2 and 2. Let's quickly add a bump 2D node. Set the bump height to something very low, like around 0.008 centimeters. Use the same texture as the bump map input and connect the bump 2D node to the normal input of the shader. We can copy the noise bump mapping from one of the previous shaders. And connect the output of the bump 2D node to the normal input of our existing bump 2D node. And this is a very quick metal shader. Let me show you the final render. If you want to change the whole feel and look of the shader, simply change the texture that controls both the specular roughness and bump mapping, and this will give you a totally different result. Let's quickly create a copper shader as well. Simply duplicate the gold shader and rename it to copper and assign it. And in the standard surface shader, change the preset from gold to copper. And that's it. You can change the base color, maybe add a bit more saturation to make it a redder copper, but that's good for now. And let me show you a high resolution render for this shader as well. So that's how you approach creating different shaders in Arnold in their simplest form. Obviously, these can get much more complex than this, but now you have a very good foundation to build upon. It's a very simple approach. Specular roughness is the key to everything, and you build around it. So in this lesson, we'll learn how to create shaders like plastic, parquet, concrete, gold, and copper. Make sure to visit our website mographplus.com or our Gumroad page at gumroad.com/mographplus and check out our premium CGI and rendering courses for Cinema 4D, 3ds Max, Maya, Arnold, Corona, V-Ray, Redshift, Octane, and so on. See you in the next video.